Hey guys, I'm doing this homework assignment again because apparently the first time I uploaded it there wasn't any audio, so here's to hoping that this one will have audio by the time I'm done. It should. Okay, so for number one, the graph of the function with f of b being greater than f of a just means that this point is greater than that point. That's what that means, is shown from a to b. The derivative of f exists for all x from a to b except at x equals 0. And that looks like it's going to be the case. Looks like we have a cusp right there. For how many values of c, so how many times in this interval will this be equal to this? Now this means instantaneous rate of change. This means average rate of change. So how many times in this interval? So right here, secant line, and we know that the slope is equal to the average rate of change. And so if I were to have a tangent line here, so say I copy this right here. If I have a tangent line right here, this is a tangent line, and its slope is equal to instantaneous rate of change. So here's one instance where that's going to be the case. Oh man, right here would be another instant where that would be the case. And then probably like right here, that's going to be a third instant. And then right here probably is going to be a fourth case. So I would say 4. For 2, let f be the function defined right here. Of the following values of x, which does the line tangent to the graph of f have the greatest slope? So what we're doing here is finding the derivative of this right here. So because the tangent line, the slope of the tangent line is the derivative. So, and we're going to use our calculator for this problem as well. So let's go to our calculator. Okay, I'm pulling up the problem so I don't have to look at it. Okay, now what I would do is just first I'm going to make sure I'm in radians, which I am, and I'm going to go to math, option 8, and then I'm going to type in the function. So that's going to be x to the 4th. Oh my goodness, it doesn't let me. If I press down, I hate this so much. Do I just like keep no? Oh my gosh, I hate this. Okay, looks like I'm typing it in here. So x to the 4th, and then plus 0.5 x to the 3rd minus 5x squared plus tangent of x divided by 2. Okay, now that I have that there, go back to math, do option number 8, vars function y1. Hopefully you guys remember how we did that in class, but I'm just going to skip over that. And then I'm putting in -2 for x, and I get -4. Yeah, so I get -4.287. So my slope here is x, we'll say this right here. We'll say slope equals -4.287. Let's go another way of, no, let's be mathematically correct. We'll say, how about this? Slope is equal to f prime of -2, which is equal to -4.287. Okay, and then -1. So f prime of -1 is going to be equal to, if I go back to my calculator, I'm just going to copy down this line right here. I'm going to change this to be -1. To enter, I get 8.149. 8.149. So you do the rest of that. Again, just go back here, copy this down. You can do 0. To enter, you get 0.5. ... Find the which one. It's going to be B, by the way. Okay. So you can do the same. I think I did these in weird order. I should have done these in a better order. 2 and 5 are very similar in what you do. So, yep, very, very similar problems. Okay, so I'm not going to do 5. But for 3, so let f be the function given by this right here. What is the value of f prime of 2? So just type this out and then, yeah. So that's what you're going to do for 3 and 4. You're just going to, in your calculator, type in the function and do the derivative at 2 and the derivative at 1 and see what you get right there. So that's all you're doing for 2, 3, 4, 5, just plugging those in. Okay, for 6, the figure above shows the graph of f, which has a vertical tangent at x equals -2. So, or sorry, at x equals 2. So at 2, we have a vertical tangent, so that means slope is not defined there. And a horizontal tangent at x equals 4. Okay, that means that slope is defined here. Slope is 0. Which of the following statements is false? So f is not differentiable at -1. -1, because we have a jump discontinuity. That is true. F is not differentiable at 2 because the graph has a vertical tangent. That's also true. F is not differentiable at x equals 4 because the graph has a horizontal tangent at 4. That's false. We are differentiable at 4 because the slope is 0. D, f is not differentiable at 6 because there's a removable discontinuity. That's true. So C is the correct answer. Which of the following statements about f, if true, cannot be used to conclude that f is defined at x equals 1? So the limit as x approaches 1 of f exists. Oh, there you go. So what we're saying here, so say that we had a graph at x equals, let's say we had a graph, and let's draw something that like this right here. So at x equals 1, the limit exists. That just means that the graph from the left is going to the same place as the graph from the right. But there could be a hole here, and the limit would exist at x equals 1, but we're not defined here, right? Now, the other case is, so f is continuous at 1. If you're continuous, then the slope from the left and the slope of the right have to be the same, but you also have to be defined as the same point. So if we're continuous, we're defined there. If you're differentiable, differentiability is stronger than continuity. So meaning that if we are differentiable at x equals 1, we're also continuous at x equals 1, which means we're defined at x equals 1. So we could use those. And the line tangent to the graph at x equals 1 exists. So if there's a tangent line at the graph of f at x equals 1, that means that slope is defined, which means we're differentiable, which means we're continuous, which means we're defined. So A is the one that we can't use. Even if it is true, we can't use it to conclude that f is defined at x equals 1. Then at 8, let f be the function defined above. Which of the following statements is true? So I'm just going to go ahead and graph this really quickly in my head. So x squared minus 20. So x squared minus 20 for x is less than 5. So minus 20, so say that we had minus 20 here. Now if I plug in 5 into the function right here, that's going to be 25 minus 20, so it's going to be 5. So let's say at x equals 5, we're somewhere like right here, something like that. will be 5. Not to scale for sure. So we're looking something like that right there. And is that closed dot? No, open circle right here. Then for this function, it's the same graph but upside down, meaning that at positive 20, we would go down here though at negative 5, and we'd start again. So we'd have, like a closed circle here, and it'd be going down like that. So, right, because if I plug in 5 right there, that's going to be negative 25 plus 20, so that'd be at negative 5. So this is 5, this is negative 5 at x equals 5. So f is not differential at x equals 5 because f is not continuous at x equals 5, right? F is not differential at x equals 5 because we have a sharp corner. Nope, we don't have a sharp corner. F is not differential at x equals 5 because we have a vertical tangent. Nope, no vertical tangent here. And f is not differential at x equals 5 because f is not defined. No, we're defined. So yeah, it's A. Okay? And that's everything for this homework assignment.